Well, welcome to Breakout Session 2. This is all about talking about how we can optimise our network and our planning using the Greater Brisbane area as a case study. My name again is Gerard Riley. I'm the Group Manager of Stakeholder Relations, and I'll just be helping facilitate today's session, which is probably the easiest job here in the whole room because you guys will be doing all the work. So I look forward to seeing you guys work constructively over the next hour and a half. Why am I using the microphone in such a small room? It's not because I have a need to use the microphone every time I speak. It's just because this session here is being recorded as well, and so we need to use the microphone so that we have good audio for our video as well. So just in terms of the structure for today, Mahesh, if I just get the... With me, we have Ian Lowry, who works in our investment and planning division at Powerlink. He's going to run you through a presentation which will go for about 30 minutes, talking about a lot of the things that we need to take into account when we're looking at the long-term planning of our network. And there's some real sort of trade-off questions that we need you guys to think about and give us your thoughts and views on. There's different ways we can go about it. We are very early on in the planning process, so we are at a stage where we're really looking for thoughts and views to make some better decision making from our perspective. And after that presentation, we will then do some table work. We'll break into sort of 3 groups. So at the moment we're sort of spread across 5, but we might sort of convene around 3 tables. Some of us might be sitting, some of us might be standing. You see that we've got some maps around the room. We want this to be a very interactive, paper-based session. We want you to ask questions. We will try and provide answers, but today it's really not about us providing the answers. It's about you guys telling us what you think, what we might do and what we might not do. Then, with about sort of 5 or 10 minutes to go, I'll ask you to try and prioritise. So out of everything that you've sort of heard in this session, what do you think are the top 3 things that we need to do and consider as part of our network planning, particularly in the Greater Brisbane area moving forward? And then we will go back out into that other room at about 10 to 12 for our final wrap-up. So without further ado, I might hand over to Ian, and he can run us through the presentation.
Thanks, Gerard. Again, probably just to reiterate Gerard's comments, really value people's time here today. This is something a little bit new for Powerlink and certainly a little bit new for me in terms of talking about investment decision making at this sort of early stage. So I'm very happy to get people's input and challenge and get into that process. Probably want to get into the actual case study quickly. We sent out some pre-reading a couple of days ago, so hopefully people have had an opportunity just to at least get their heads around that. Importantly, it's probably those questions on the last page of that pre-reading. We wanted to get in people's minds as I'm going through the presentation so that anything that I'm talking about really sort of is framed in the context of those questions once we get onto the table. So just direct your attention to those. I just want to talk briefly about the operating environment. I think Stuart actually covered that quite well in the main presentation, so I won't linger on that particularly about the changes we see and the challenges it presents. Also just talk about, I suppose, those factors that we see are contributing or feeding into this question about optimising reinvestment decisions in our network, and really get into a case study on the Greater Brisbane area. So we've been doing some early stage planning. If some of you had the opportunity to read our annual planning report, we do talk at a high level about the fact that there are potential options to reconfigure the transmission network in the Greater Brisbane area, and that we're still really kind of thinking through those potential solutions. So for the purpose of today, we're really just trying to present a comparative case study to get some discussion going about those trade-offs. So with regard to operating environment, as Stuart touched on in the main session, we have now an amended reliability standard. I suppose that's quite key in terms of our thinking of the latitude that we might have in terms of potential future solutions for the Greater Brisbane area. The demand forecast outlook across our network at the state level is essentially flat, and I'll show you a bit later in the presentation that is effectively replicated in the southeast Queensland area. That trend is very much the same. We have, and you would have seen, certainly got the emphasis from the main presentation that substantially most of our capital investment plans in our outlook and in the APR are about reinvestment in our transmission network. We've got quite a number of assets that were constructed in the 60s and 70s that are approaching their end of technical and economic life. And that's certainly an issue for us in the Greater Brisbane area. In the pre-reading material, actually, if you've had a chance to look at it, you'd actually see the quantum of transmission lines that are approaching their end of life over the next 5 to 10 years. Quite a lot of things flash up in the dotted lines. I suppose the thing to emphasise here, and probably just to sort of put a bit of shape around it from Powerlink's thinking, is that those three factors in combination net to one simple point, which is that we're now reinvesting in assets but without the growth. And I think that's probably just an important point to bring out from the perspective that in the past, when we've been making these sort of decisions to either reinvest or to potentially retire, well, particularly to reinvest, it's in the context of loads that over time had continued to grow. And so those decisions were always, I suppose, supported by that ongoing demand for our services in the back end in terms of a decision-making process. What's quite different now, clearly, is without the growth, we need to be much more clear about the enduring need of those assets and understand the requirement for them going forward. And that's really, I suppose, the key thing that's driving us to have a look at scenarios like the Greater Brisbane area in a lot more detail. So as I said, that change in environment allows a change in approach in considering reinvestment decisions. I think I've touched on the vast majority of those points that are made in this slide. The only other couple of things I'd probably like to mention around impact on stakeholders, and it's certainly a theme that we'd like to talk about today. Some of our future plans for the Greater Brisbane area might impact landholders and community to varying degrees. And so we're certainly very cognisant around the concept of social licence to operate and how we're making investment decisions that are cognisant of our relationship with community and stakeholders. And another factor which I suppose quite impacts our thinking that I'd probably choose from that little optimisation diagram is around utilisation. Obviously, some of the decisions we make can have the effect of either improving or reducing or decreasing network utilisation. That's something we're quite cognisant of when we're thinking about these sort of longer term plans as well. Ultimately, I suppose the point of this is to say that we're absolutely trying to take a holistic approach to thinking about all of those factors and feeding them all into the hopper and thinking, well, okay, how does that position us in the future in terms of our investment plans? Always with the eye to the lowest long-run cost to consumers. So, onto the case study. As I mentioned, we had talked in our transmission annual planning report about the Greater Brisbane area. So we're really just extending on some of the themes that we raised in the APR this year. And the other thing I just wanted to acknowledge up front is that as we go through this case study, it is quite simplified. There's been quite a bit of work going on in the back end, but cognisant of time, we're really trying to put up a problem today that looks at two alternatives, fully acknowledge that there are a lot more solutions that we could potentially consider, but these two seemed useful for the purpose of the conversation today. So in the Greater Brisbane area, we're thinking about these longer term plans. As I mentioned before, the statewide forecast, in effect, you can replicate into the Greater Brisbane area. Half of all the transmission lines that form part of that network in the Greater Brisbane area are expected to reach their end of life within around the next decade. So it's quite a significant challenge to think through how we'll manage reinvestment in those assets. We'll have people here today who'll be able to talk to this in more detail, but obviously being in this urban built-up industrial commercial area, the easements and the operating environment could be quite constrained. Our ability to actually implement different project solutions, we've got to be cognisant of, whether we can actually rebuild or whether we have to do all the work in the confines of an easement. So a lot of those factors obviously impact our decision making as well. Now I just added this in, I suppose, as much as this is a case study about the Greater Brisbane area, a lot of the themes in this reflect the situation across our network, with the demand being as it is. And just anyway, this takes my fancy. A simple snapshot that we have an average of 400 transmission towers which reach 50 years of age every year for the next decade in our network. And that's an average. I think the rate's actually increasing, but if you put an average through it, that's the sort of shape we're in. So that's why you can see there was quite a long list of potential reinvestments contemplated, and Stuart spoke to that in the TAPA forum. So with that much of our transmission line asset base reaching 50 years of age, which needs to have us thinking about how we might reinvest, and in a flat demand growth environment, we certainly are cognizant of needing to think about how we invest in those assets differently. Thanks, Mesh. So very quickly, I just wanted to, I thought this might be useful context, just sort of explain the build-up of the network over time. I'm not trying to give everyone a history lesson about the development of the network, but nonetheless, what we've done is we've just petitioned 15-year blocks since 1960 just to give people a sense of how things developed. So between 1960 and 1975, in phases, this is effectively how the network developed. I think everyone probably read that, but the blue is the 110 kV transmission line and substations, and the purple is the 275 network. Obviously, in the early 60s, we had Tennyson Power Station, Swanbank A Power Station providing the majority of generation into this area. And in 1963, the 110 kV network was established. Along came Gladstone Power Station and Swanbank B, and supply was augmented from CQ to SQ, and the 275 network here was developed around 1971. So that, I suppose, is really those tranche of assets which are coming within view to think about reinvestment. Interestingly enough, the load growth at that stage was up to around 900 megawatts. Thanks, Mesh. Time moves on. 1975 to 1990. Toorong Power Station, the first unit was commissioned in 1984, and so there was augmentations which took place to bring some of that power into the southeast. Loads were growing from about 900 to 1900 megawatts. So again, loads picking up over that time, and I suppose in the main, that reinforcement and some other minor reinforcements and reconfigurations of the 275 network occurred over that time to support load growth. And then, thanks, Mesh. From 1990 to 2009, loads again picking up from 1900 megawatts to around 3,500 megawatts, which is what we saw in 2009-10 peak summer demand. Someone correct me if I'm wrong, I think that's the right financial year, to 3,500 megawatts. And again, what we saw is further reinforcement into southeast Queensland via Moomerran Middle Ridge into Greenbank and supply up into Belmont, and further reinforcement of the supply into the Gold Coast. So Stuart made that statement around the lower voltage networks, then higher voltage being overlaid on top as the loads develop. That's certainly the situation for us here. And what it leaves us with in the net is all of those transmission lines which were constructed between 1963 and about 1975, approaching end of life in the next 5 to 10 years. So that's really the nature of the problem, so to speak, that we need to think about and address. So one thing that I just wanted to touch on is what's the need? What do we need to do? I've provided some useful photos of a very small sample of photos, which just is really to indicate that there's corrosion matters coming along. A lot of what we're focused on in the Greater Brisbane area involves two key factors, really. A lot of they're all steel lattice construction. There's loss of galvanising and structural corrosion that's emerging. Obviously, there's a lot of components on a transmission line which are degraded to varying degrees. In terms of structures, we'd expect those to last at least 50 years in this environment. Components, they last anywhere between 25 and 40 years, depending upon if we're talking insulators or earthwires. The key thing I'm trying to bring out here, though, is that on all of these assets in the Greater Brisbane area, the conductor's in good nick, it's in good condition, and the rating's acceptable based on all of the demand forecast outlooks we see. And generally, we expect the conductor to actually last 80 years. Equally, the foundations, because of the conditions here, they're all in good condition as well. They should also last for around 80 years. And I suppose the point of that is to say you can't treat the transmission line as one structure and all of its parts clearly as the same element. And so, given that we think that we can push these assets to that 80-year mark, our real focus is on dealing with making sure the structures are sound, they're safe and reliable, and that any components on those structures that we're replacing at the right time in order to again manage safety and reliability risks. I suppose the net of this is that we're not minded to replace any of these transmission lines, where our focus is really, because of this situation, is to try and push them as much as we can. And Mahesh, if you can just move on. And it just probably leads into this concept of line refit strategy, which I just wanted to touch on briefly. Because it is only about structural corrosion, what we're actually looking at, and as was mentioned in our APR this year, is a program of what we call line refit. What that's basically about is that we look at each structure and we determine those small percentage of structural components and bolts and members and things that might need to be replaced. And on occasion, and depending upon the sort of life we think we need to get out of those structures, we might actually paint them as well. Certainly what that offers us, and it's a strategy which we've been focused on for some time across our network, is a lower cost, more incremental way to extend the life of transmission lines. We can design structural refit programs for various extensions of life depending upon our view on the enduring need for those assets. And it certainly reduces the emphasis on pulling forward capital expenditure and putting in high value assets. And certainly in this area, that's something that's probably not particularly plausible in some parts of this network, given the access and easement constraints. So I suppose we see that strategy gives us that flexibility to deal with what you might call an uncertain future. I've spoken a little bit already about this, but in effect, this represents the forecast for this Greater Brisbane area. For all intents and purposes, it's absolutely reflective of the state level forecast in terms of a flat demand outlook. The network, as it stands at the moment, is capable in its current configuration of actually servicing quite a substantial component of additional electricity demand. And for that reason, when we're looking at some of those assets that might be approaching end of life in the next 5 to 10 years, there's a clear opportunity to look at reconfiguring the network or potentially retiring assets. I just note, and picking up on Maren's earlier comment, that forecasting is invariably never correct. And we do have to acknowledge the fact that in this area, while that's our forecast, there are other forecasts. And just to give a quick mention, we're quite aware that Energex at the moment would be forecasting a modest increase in demand across this area, speaking generally. And we're also cognizant of the fact that AEMO, on a state basis, is forecasting around, all things being equal, let's call it a 1% per annum load growth at a state level, which we think would be analogous as well. So we're cognizant that our assessment of the demand here is as it stands at the moment, on the lower bound of some of the forecasts that are out there. And so we have to obviously consider that. So, as I said, what we want to just move into quickly is a discussion about two options that we've got. In the face of uncertainty, and given the constraints in terms of getting access to this network, we could seek to maintain the existing network. We could implement the line refit strategy, try and take a low-cost incremental approach and push those assets as far as we can. And I suppose, so our base case option that we wanted to talk about today for the purpose of getting some discussion going is really around option A being low-cost reinvestment in the existing network assets. And then Mahesh. The second option, which certainly presents another perspective on what is possible with this network, is around a reconfiguration. Broadly speaking, it would involve radialising most of the 110 kV mesh network in the Greater Brisbane area. For the purpose of this diagram, as I've mentioned before, the dotted lines show all of the assets which are coming towards end of life, and the green is to indicate where, based on planning studies, considering the current demand forecast and also thinking about the amended reliability standard, there's a potential for actually retiring some assets. So those are between Upper Kedron and West Darra, Goodna on the south-west Brisbane into West Darra, and on the Brisbane South area between Richlands and Algester. As I said before, this is one of a number of possible network reconfigurations that we've been testing, but for the purpose of today, we just thought this might be a helpful one to get some discussion going about trade-offs. How's everyone going with that? Is there anything questions jumping out at all? Oh, Katrina. Two, straight up.
What does radialising?
It just means that the 110 kV bulk supply points would be supplied radially from a 275 to 110 kV transformation point, I suppose. So in effect, there's no interconnection between the 110 kV network or vastly reduced 110 kV meshing of that network. So.
And when you talk about the assets coming towards the end of their life, and then you outlined that, some parts have a year life and some have 50 and some have less, are you talking about sort of approaching the 50?
That's right. So, and that's probably the distinction I was trying to draw there, is the fact that it's not all aging in the same way, and it's not all in the same condition. So we're really trying to design a reinvestment approach that caters for that. That's, yeah. Okay. Yeah, Christian.
There are a lot of old assets in the system. You mentioned that capability is still okay. How Powerlink actually assess rating of assets versus aging on the assets? Is there a decrease? Of course, it doesn't mean that it must be decreasing, but what is your philosophy?
I think I'd like to throw to one of the... Where's Rodney? There he is. Let's have one of our planners answer that one.
Plant rating versus aging of the plants. Do you decrease rating with aging or?
No, so what Ian was saying is that these assets are approaching the end of their life. We don't specifically apply any reduction in the rating of the asset as it approaches its end of life. So the answer to that is no.
Yeah, I suppose I may not have made that clear. What I was really trying to say is, in terms of meeting the load, the ratings, the conductor ratings and the ratings of those lines is appropriate into the future. So we've not got any concern, as we might have in the past, with loads growing and having to think about what the rating of those assets might need to look like in the future. It's basically a stable environment from that perspective.
And that model is based on 50 megawatts risk.
Actually, that's what we're just going to get into. Is I'm just going to talk about what the implications of this potential option are, so we can sort of see some of the trade-offs.
You may be covering it later on. I'm just wondering, with the system reconfiguration, it appears to be focused on the 110 network. Is there any subsequent impact on the Tarong limit or the southwest limit as such? The capability of the network, will there be a reduction?
To come into there, and again, Rodney, you want to?
Yeah, so we do expect to be a slight reduction of the limit, because, as you know, the limit is, you might know that the limit protects the reactive margin at Blackpool substations. So it protects the reactive margin at the Blackpool substation. So as soon as you start to reduce the network, you start to increase the losses, which will start to erode that reactive margin. So we do expect there to be a slight reduction in that limit, but not substantially so.
So that would be for system normal, but then if you have outages, because you do have outages on the system, would that have a sort of a flow-on effect then
So
also?
when we do establish the limit, it is based on an n-1, so it takes that outage into account.
But that's true, but what I'm saying is that when you have an outage, what sort of flow-on effect are we going to see in reduction of capability across those limits? Because there are times when you need to have an outage. We saw the Calvo-Halley's line come out just recently, and that was well managed. We had the information, but that impacts on two key limits: the Southwest SWQ and the Central South. So I'm just wondering, the Tarong limit, not the SWQ. So they're quite inputs, and that one actually bounced at that time. So if we now start lowering that capability, both the system normal and n-1, does that tighten up the supply demand into that southern area?
Okay, well, that's something we might...
I'll just leave that.
We should definitely pick that up in the breakout sessions and take that away. So just moving on to some of the trade-offs. Just to explain this table, we tried to effectively bring out simply describe as best we can some of the parameters around the decision-making process. And for the two options I talked about, which is effectively retain the existing network and then look at an so-called optimised network configuration, just look at the basic differences in these parameters. So I'll just try and step through them. The first one's quite obvious. Between the existing network and the optimised network, that plan, that option would involve retiring around 30 kilometres of transmission line in the Greater Brisbane area. In our view, that would lead to an initial cost saving. So this is framed in terms of total expenditure within the first 5 years of the strategy of around $10 million. In NPV savings terms, so this is more with regard to forecasting out all of the future expected capital expenditure, operating expenditure, decommissioning costs. We tried to bring in all of the elements of the expected costs of both of those options going out. We actually see that the sort of potential solution we're talking about, where we'd be retiring some of those assets, would lead to around a 20% saving in NPV terms. So it certainly grabs your attention in the sense of a potential lowest long-run cost solution. That being said, and there are obviously a range of issues to consider, something like as Henry raised, but when we're thinking about this problem, we just wanted to sort of try and find a straightforward way of conveying what the impact is. And so we've got two lines here. The first one is around demand growth before load is at risk. So that's demand growth that we think we could see in the Greater Brisbane area before we exceeded an N-1 criteria, where we saw an N-1 limitation. Now, as both Merrin and Stuart touched on, that is not our reliability standard, but it at least sets the scene for indicating when, during that peak summer day, a contingency event occurs, the potential for losing some level of load within the limits that Stuart mentioned in the main forum. So our existing network has, as we like to call it, headroom capability. 25% withstand to growth based on the summer's just past loads. The effect of making the sort of decision that would come about under that option would be to reduce that headroom capability against an N-1 limit to 0. Now, this analysis has been done on a forecast basis. It's been done on the basis of ramping up loads across all the connection points consistently in terms of testing and looking for a limit. So I acknowledge that it's not taking into account and weighting demand growth in various areas across the Greater Brisbane area. But nonetheless, I suppose it paints the picture that for around that 20% NPV saving, the corresponding trade-off would look like taking the network capability from 25% to 0% against an N-1 limit. So that's the point at which load might be at risk during those peak summer periods in a contingency event. The second sort of criteria that we're thinking about is how much demand growth can we withstand before an augmentation is required. So this is now about applying the amended reliability standard in our N-1-50, which allows that load at risk, us to plan for some level of load at risk during a single contingency event. Obviously, it gives us more headroom. So we in fact estimate that we could withstand, globally speaking, around 40% growth across the Greater Brisbane area before such a single contingency event would exceed that amended reliability standard. And if we went to the sort of proposal that we've talked about today, we'd still probably, again, on a broad basis, estimate around a 10% withstand to demand growth in order to remain within our reliability standard. So I think the key takeaway here is there's certainly NPV savings to be had by the sort of option in our, that we're talking about as an alternative, in our view, that there's a trade-off in the demand growth we can withstand before there's a portion of load at risk. But nonetheless, this sort of option, all of our analysis tells us that it's actually within our amended reliability standard. So therefore, it's feasible from that perspective. There are another couple of trade-offs that we've just attempted to frame at a high level, and these probably would just jump out at people anyway. Operational flexibility. With our current network configuration, we can effectively take the most critical element in that, which is in fact a supply into 27 supply into Rockley, out of service during winter period, and generally speaking, based on loadings, we wouldn't expect to see much of it all load at risk. The obvious impact unmeshing the network is that for that same scenario, there's load at risk during that planned outage of something in the range of 150 megawatts we would expect.
Just to be clear, so sorry, are you happy to have a running conversation, or do you want to keep on going?
We might keep going because the only risk, we just lose your questions. We just want to make sure that we actually get them, save them all, Henry. Yeah, no, that'd be good. So I think, that's really just to indicate that, not that we have 150 megawatts that would be shared, clearly. It's simply that we have to make sure we plan our outages very carefully within those low periods. We think about maintenance intervals and project outages. We think about return to service. So in effect, the first thing anyone would feel is actually just Powerlink in effect in terms of our flexibility to manage outages for this sort of option. So we'd certainly be interested in any views that people have on that. And finally, and probably in our minds, one of the more challenging things to think around is about future access to easements. As I mentioned before, and I think I'll show a photograph that shows in some cases the very built up areas that we're going through, particularly around the south of Brisbane. And a decision to maintain the existing network, the works are on the easements, we continue to maintain the works, manage our easement conditions, and things are good from that level, from the perspective of flexibility. If we went to a point of retiring and then deciding to decommission those lines, I framed it as such as an incremental reduction in flexibility. Some people might say you'll just never get back. As sort of a commonly held view regarding access to those easements. So clearly there's an assessment of risk that we have to make in that we're cognizant of, but nonetheless that's something that weighs on our minds as well. We have to be thinking about when we might need those easements in the future, clearly, and what the impacts to us would be if we couldn't get access to them, and that's really part of the analysis. So they're really the sort of, we just tried to map through some basic parameters, so in terms of trade-offs, and I suppose that was really to get people's thinking flowing around some of the questions that we'd like to ask. Ultimately, and this probably touches on some of the points I've already made as I'm going through, that optimised network configuration to us could quite reasonably be put forward as a lowest long-run cost solution. The reduction in our headroom capability, while it is quite considerable, it still remains consistent with our amended reliability standard. We do see incremental improvement to network utilisation because obviously the flows changing without the meshing of the 110 kV network. And something that we're incredibly mindful of is reinvesting appropriately. And I suppose we need to be cognizant that we're not reinvesting in assets without an enduring need. We've obviously got to convince ourselves of the benefit of that. But nonetheless, this sort of scenario does take away those initial costs and then the ongoing costs of total expenditure to maintain those assets if that's the direction we chose to go. So, I'll just talk to these briefly, but they're really we're getting basically to the thrust of why we're keen for feedback. And so you probably get the gist of some of the issues that we're thinking about, and they probably jump out by virtue of the case study. But theme one's about network resilience. So how resilient is our network to change or uncertainties in the external environment is really the first theme we wanted to capture. Obviously, that's in the sense of the trade-off between lowest cost and network capability for the future, acknowledging forecasting uncertainty, as was talked about earlier, thinking about aspects such as operational flexibility within that network, or as Henry's alluded to now, potentially on limits impacting outside of the more local area, and around resilience in terms of being able to get future access to land and easements. So they're factors that are obviously exercising our minds in this decision process. As I said, these decisions are probably 5 to 10 years out, early stages. We don't have comprehensive analysis of all the answers, but we thought today it might be useful to start to get people's views on the things we should be thinking about. Just the next one, thanks, Mesh. Another theme for us is the strategic value of land. So how to best consider the strategic value of land and easements in urban areas and constrained environments. I won't read these to you because they're actually in the pre-reading and we'll go through them at the tables. I think Melissa was able to provide this for us just to give a taste of, I mentioned South Brisbane. Rightly or wrongly, over time, this is the aerial shot of the corridor that we've got through here, and you can see transmission lines and you can see backyards and houses. So we're talking about some very constrained corridors where, and it's not consistent or homogenous across easements, but clearly from getting a transmission line from A to B, the decision to retire one, in our view, at least to get back with similar infrastructure, would be reasonably permanent, I suppose. And the last theme is around stakeholder impact. We've then got to consider the knock-on effects of deciding to retire an asset. And this has been a theme which is coming out in other network companies as well. People are thinking similarly. Okay, so you can retire the asset, but how do you retire it? And how do you get the balance between retiring it in a low-cost way, but also making sure that the thing that's sitting out there with public access is safe and reliable. And so there's more than these, but broadly speaking, 3 types of options. Obviously, we could think about decommissioning and removing them. If we chose to retire them, we could just electrically disconnect them and make them safe, mechanically safe on the easement. It's an option. Or we could try and retain under maintenance for as long as possible. And I think in some ways it may not be one or the other. It could be one or all of them as options in terms of phasing the costs of doing this sort of thing. So we did want to have a bit of a talk about people's perspectives on that question and how we best manage the trade-off between retiring at a reasonable cost, but also making sure that the works that are out there in the public environment are appropriate. So that is, we've come to the end of my presentation, and hand back to Jared.